Hey everyone, today we're learning some shortcuts. First up, Lambda Functions. Imagine you need a tiny function just once, maybe to square a number. Defining a whole formal function with definite feels like overkill. A Lambda function is a throwaway one-line function. The syntax is simply lambda arguments, expression. It automatically returns the result without needing the return keyword. Now let's use lambdas with the map function. Imagine you have a list of prices and you want to add tags to every single one. You could write a for loop, or you could use map. Map takes a function and a list, and it applies that function to every item automatically. It's faster, cleaner, and perfect for simple transformations. Next is filter, and the name explains everything. Filter takes a condition and keeps only the items that return true. Everything else gets removed. For example, filtering a list of ages to keep only people who are 18 or older. Combine it with a lambda, and you get a powerful one-line way to clean your data. Finally, we have reduce. This one comes from the function tools module. Reduce takes a whole list and compresses it down into a single value. Think of adding numbers. It takes the first two, combines them, then takes that result and combines it with the next, and so on. By the end, you're left with one final value. Filter and reduce often work hand in hand. Filter helps you clean your data by keeping only what meets a condition. Then reduce takes whatever remains and compresses it into a single meaningful value. First you sift out the noise, then you squeeze the results into one final answer. Together, they give you a powerful way to process data efficiently. Welcome back. Before we understand decorators, you need to know a secret. In Python, functions are just variables. You can pass a function into another function, just like you pass an integer or a string. This allows us to create higher-order functions. In Python, functions are more than just reusable blocks of code, they're actual objects. That means you can store them in variables, pass them as arguments, and even return them from other functions. When we pass one function into another, we're literally handing over behavior for the second function to use. A decorator is a function that takes another function and extends its behavior without modifying the function itself. Think of it like a gift box. The gift, your function, is inside. The wrapper, the decorator, makes it look nice, but doesn't change what's inside the box. We use the add symbol to apply them. Let's write a simple timer decorator. We define a wrapper function inside our decorator. This wrapper starts a timer, runs the original function, stops the timer, and prints how long it took. Then, we just add timer above any function we want to measure. It's reusable magic. Why do we use this? It's perfect for things like authentication, checking if a user is logged in before running a function, or logging, recording when a function was run. You write the logic once in the decorator and apply it everywhere with a single add symbol. Generators and yield, memory efficiency. Now we're talking about efficiency. Imagine you need to process 1 million numbers. If you create a list, 1, 2, 1 million, Python creates all 1 million numbers instantly and stores them in your RAM. This is slow and memory heavy. What if we only need one number at a time? This is where generators come in. The yield keyword is what makes a generator special. When your code reaches a yield statement, it pauses the function, returns a value, and remembers exactly where it left off. When the generator is asked for the next value, it simply resumes from that point. It's like hitting pause, sending the result, and then continuing the moment you hit play again. Using next and iterators. When you call a generator, nothing actually runs yet. The work begins only when you call next. Each call steps the generator forward and produces the next value. One step, one value, no extra memory, no wasted computation. This is lazy evaluation. The generator computes only what you need exactly when you need it. Generator expressions. Generator expressions look just like list comprehensions, but they behave very differently. A list comprehension builds every item immediately, storing them all in memory. A generator expression creates items one at a time as you iterate. That means tiny memory usage and huge performance savings for large datasets. One line of code, massive efficiency.